Howdy! This is your friendly neighborhood physics teacher, and I am here to review you over net force. That's also resultant force, that's also total force. So, remember, net force, here, so net force, resultant force, and total force all mean the same thing. They all mean the same thing. Net force, resultant force, total force. All means the same thing. So, your net force, the equation for net force, which will be given to you, is your mass times your acceleration. That's your basic formula. Your net force can also be, think about a net. Think about net. With a net, you're trying to catch all the little fishies, right? Swimmy, 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 little fishy, swim, swim, swim. Your net, the whole point of your net is to catch all of your fishes. Same thing about your forces. You want to catch all of the forces. Little forces. And that net force, you want to catch all of your forces. Now, just like in fishing, you have some nets that are there to catch fish, and you have some nets that are there to catch like crab and lobster. And so there's two different types of nets out there. There's just two different types of net forces. To be specific, so can't forget about. So we have our fish, little fishes, and we also have our little crabs or our little lobsters. Lobsters. I am doing this very quickly. Don't make fun of me. Blah, blah. Have to have antenna because they're little bugs. So, then you have nets. They're supposed to catch your lobsters also. And just like this, you have force in the x direction. You want to catch all the forces in the x direction, and you want to catch all the forces in the y direction separately. Okay? So we have two different types of nets. We have net force in the x, and we have net force in the y. And just like the fishermen, you don't really want to get them combined because you use two different nets. You use a little softer net with the fishes, use a harder net with the lobsters. So you have your net force in the x direction, still equals the same thing, your net force in the y direction. And again, think about your direction, just think about your graphing. You have your y-axis and your x-axis. So your x is horizontal. So this is horizontal motion. So this is horizontal motion. Anything that's going in the horizontal. Your y is your vertical motion. So anything that's going up or down. So this is up or down. This is left or right. So let's look at a basic little free body diagram. Click. We have a box. Now, what force is always there? It's the first force you're supposed to, you would shout out. Hopefully y'all are shouting out gravity. Yay, gravity! So force of gravity always points down. And since we're on a flat surface, our normal force points up. Let's say we're having a force applied, it's being force being pulled that direction, and we can't forget about our force of friction. So we have force of friction this way. Again, so you have to think about all the forces in the y direction, and then all the forces in the x direction. All the forces, give me back my pencil. All the forces in the x direction. So you have your net force in the x, in this case, would equal your force applied, minus, would equal your force of friction minus your force applied. Why do you subtract when we say? Because they're going in opposite directions. And our force for y, net force in the y direction, would be your force of normal minus your force of gravity. So, and that's where that comes from. So, kind of think about that. Is it moving in the y direction? Is it moving in the x direction? All the problems on our test, it's not going to be moving in the y direction. So, since it's not moving in the y, not moving in y direction, what that means, it's not moving up or down. So the net force in the y is 0 newtons. So therefore, if we go back to our equation, net force is 0 equals our normal force minus our force of gravity. So that's, and then we can kind of balance it out using algebra. And that's how we get our force of gravity equals our force of normal. Because it's balanced, it's not moving. So, there you have it. With your force of net in the x, it's according if it is moving or not now, or if it's moving at constant velocity. So if you have an acceleration, okay, I can't spell. If you have an acceleration, that means you do have a net force in the x. That means it will be a number. You'll actually have a number, a tangible number. But if it's not accelerating, I can't spell. If it's not accelerating, that means your net force in the x is equal to 0. And if it's not accelerating, you have two choices. It's either A, it's not moving, like our y direction over there, or B, it's moving at constant velocity. So both of those will get you a net force of 0. And again, you would just set them equal to each other. But if you do have acceleration, you do have a net force. Okay? So that's kind of the logistics of net force. Now let's do some practice problems. On your homework, you just had a brick and you had forces coming off of it. You might have had 10 newtons going this way. You might have had 5 newtons going this way, 20 newtons going this way, and 30 newtons going this way. Again, you go back to everything in the x direction and everything in the y direction. X direction, everything in the y direction. So let's look at the x direction. So our net force in the x direction would be 20 minus 30, or 30 minus 20. It doesn't, so let's just do 20 minus 30. And that gets us a negative 10 newtons. Now remember, in physics, that just means it's going in the negative direction. So if, well, in this case, I guess, hold on, back up. It would be 30 minutes, because this is what happens when you do videos early in the morning. So this, to the right is positive, to the left is negative, down is negative, up is positive. So it technically would be 30 minus 20, which would give us a positive 10. That's why you don't do videos early in the morning. I do apologize. So it does matter. And that's your frame of reference. I would suggest sticking with this frame of reference because it makes angles a little bit easier to deal with. But there you go. So you have that. So, and that's in the positive direction. So if you made a vector, it would be like that. Yay! So now let's look in the y. So the net force in the y direction, we have 10 minus 5. That gives us 5 newtons. And that means since it's positive, it's going up. And you put these two vectors together. You always draw your x vector first. Always draw your x vector first. Always draw x vector first. Always. Always, 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 always. Always, 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 always. Always, 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 always. Get the point? Okay, cool, thanks. Always draw your x vector first. Then when you draw your y vector, you put it on the end of your x. So when you draw your x, so y vector starts at arrowhead of x vector. That's another thing. So these are just things I'm seeing when you draw your triangles that throws off your angle. You'll get the same hypotenuse. You will get the exact same hypotenuse, but your angle will be off. So you draw your x vector first, and then when you draw your y vector, it starts at your arrowhead and goes up. And then you have your hypotenuse. This is your 90 degree. So it says that your x is 10, your y is 5. So how do you find your hypotenuse? You just do your a squared plus b squared equals c squared. Now, your c is always your hypotenuse. C is always your hypotenuse. Okay? Now, a and b is interchangeable. So it could be a or b. This could be a or b. That is interchangeable. That doesn't matter. But your c has to be your hypotenuse. So you do 10 squared plus 5 squared equals c squared. And I'm just going to show all my steps. C squared. Add those together. Now, I also seen people stop here. Do not stop here. It's not c squared. Your hypotenuse is just c. You have to take the square root. You have to take the square root. Yeah. So 125. Square root of that is 11.18. Okay? 11.18. That is your hypotenuse. So that is your resultant vector. So if it's just asking for your resultant vector, that is your resultant vector. Resultant vector. That is your resultant vector. That is your net force. That is your total. That is your resultant vector. Net force vector, or net resultant force. I didn't mean to call it resultant vector. It's that too, but since we're in forces, it's specifically your resultant force. But then if you ask for what direction it's going, it's asking for direction. Now your angle is always the angle that's away from your arrowhead of your hypotenuse. So your angle is the opposite opposite corner. Let's call it corner instead of angle. Opposite corner from your arrowhead of resultant force. Resultant force, aka your hypotenuse. I'm not spelling hypotenuse, that's as close as you're getting. So it would go there. Now, to find your angle, you have to do, so that's your hypotenuse, there's your angle, so that's your opposite, and this is your adjacent. So you have your opposite and adjacent. You technically do have your hypotenuse, but I would just stick with your opposite and adjacent. So you know you're going to use tan. So tan theta equals your opposite over adjacent. You don't know your theta, so you have to get tan on the other side. That's when you use your inverse tan. And in this case, your opposite was 5, your adjacent was 10. So 5 over 10. Plug that into your calculator. You plug that into your calculator. On your calculator, make sure you hit second tan to get your inverse. That gives you an angle of 84.29 degrees. And that's how you'd find your angle. So that's basically how to do one of these. You figure out all the forces in the x direction, figure out all the forces in the y direction. Subtract them, add them. If they're going the same direction, you add. So we talked about if they're going in the same direction, you add them. If they're going in the opposite direction, you subtract them. And they look like really funny faces, at least the bottom two do. And that's basically it about your resultant force, dealing basically with your free body diagrams and net force. So if you still have any questions, please feel free to email. You have 3 other videos to watch if you haven't watched them yet. Have a wonderful day and happy studying. Bye!